Hey, this is Mathdoctor, and let's begin with carbon and its compounds. In the previous lecture, we have discussed about the two allotropes of carbon, namely diamond and graphites. Now let's discuss about the third one, which is Buckminster fullerene, and it is discovered in this era, in this present era. Buckminster fullerene is an allotrope of carbon containing cluster of 60 carbon atoms joined together to form spherical molecules. Since there are 60 carbon atoms in one molecule of Buckminster fullerene, it is denoted by C60. The Buckminster fullerene is a football-shaped spherical molecule in which 60 carbon atoms are arranged in interlocking hexagonal and pentagonal rings of carbon atoms. There are 20 hexagons and 12 pentagons of carbon atoms in one molecule of Buckminster fullerene. This allotrope was named Buckminster fullerene after the American architect Buckminster Fuller because its structure resembles the framework of dome-shaped halls designed by the Fuller for large international exhibitions. The arrangement of carbon atoms in a Buckminster fullerene resembles a football made of 20 hexagonal and 12 pentagonal panels, each corner of every panel representing a carbon element in it. So that's the whole idea about the Buckminster fullerene, structure of the Buckminster fullerene. Now let's discuss some properties of Buckminster fullerene. Buckminster fullerene is a dark solid at room temperature. It differs from the other two allotropes of carbon, namely diamond and graphite, in the fact that diamond and graphite are giant molecules which consist of an unending network of carbon atoms. But Buckminster fullerene is a very small molecule made up of only 60 carbon atoms. Just like diamond and graphite, Buckminster fullerene also burns on heating to form carbon dioxide. If we burn Buckminster fullerene in oxygen, then only carbon dioxide gas is formed and nothing left when in the chemical reaction as our product. This shows that Buckminster fullerene is made up of only carbon atoms. So, an important physical property in which these three allotropes of carbon differs is their hardness. Diamond is extremely hard, graphite is very soft. On the other hand, Buckminster fullerene is neither soft or neither nor hard. So that's the idea about the properties of Buckminster fullerene. I hope you enjoyed my lecture. See you in the next video. Share with the hashtag Mathdoctor.